My name is Stephen Pennell, and I'm the coordinator of arts and culture here at the URI Feinstein Providence campus, the College of Education and Professional Studies. I bring greetings and welcome from Dean Roll, who had to leave town after the Education Summit today. So this project began actually a year ago when Professor Paul Florin, put me in touch with Honoring the Future and their Climate Change Art and Action exhibit, which is out in the first and second floor lobby. Artists from around the nation who are actively involved in creating art because of their concern for climate change. And this project is about educating communities and about empowering communities in action. In the process of this year, I discovered that there was, from September 15th to December 22nd, while the UN is having climate change discussions, there was a biennial climate change theater action event, and so Wilbury Theater produced some of the plays that were commissioned from around the world on climate change here last Thursday, along with the gallery night reception. And the third component is this roundtable, and I was fortunate enough to be able to connect with faculty from the university who are working from the university, from the Graduate School of Oceanography, and from the Coastal Resources Institute to share their knowledge about climate change around the world and locally. And we are very fortunate to have Ian Donis, who is from National Public Radio, here in Rhode Island, to moderate this discussion. So without further ado, I turn it over to Ian. Thank you, Ian.
Thank you, Stephen, and thank you for joining us tonight. We're here to discuss one of the central issues of our time, the threat of man-made climate change. There's a constant stream of worrisome news about this, as you're probably aware, like a UN report this week about the current state of the world's oceans. This evening, we're joined by climate scientists working at the URI Graduate School of Oceanography and the Coastal Resources Institute. They'll talk about how climate change is affecting Rhode Island and what people can do about it. I'd like to thank our panel for joining us: John W. King, Isaac Guinness, Pam Rubinoff, Jeremy Colley, and Howard Ginsberg. We'll hear from each of these individuals about their research, but first I'd like to quickly go through the panel about where we are right now, whether there is still enough time to prevent the most extreme consequences of climate change, and maybe if we could start at this end and work our way down. And I think we have, I don't know if you need you probably don't need the microphone, but I think it looks like there's some microphones behind you.
Well, I'll speak. My work is with vector-borne diseases, and they're, of course, intimately affected by climate, but it's not just climate that affects them. So there are already effects of climate on the distribution of these diseases, but it interacts with things like global transportation, which affects introduction of exotic species, habitat distribution. So I think you have to take all these things into account in figuring out how to respond to these diseases to protect public health.
Isaac, what would you say to the same question? Is there adequate time to prevent the most extreme consequences of climate change?
Yeah, I think so. I think there is still time to at least to level off the emission carbon dioxide. It will be difficult. I'm not very optimistic that it can be accomplished, but I think if we can at least level off the carbon dioxide emission, we'll have a chance then to develop perhaps some technological solution and to deal with the impact of climate change.
Pam, same question for you.
So I work on the people side of this equation, and if we are going to level off the emissions, as Isaac encourages us to, then people need to make change now. So I feel from the people perspective and our behavior change that we are at the time that we must act now.
John?
Not to steal another social movement's slogan, but I would say time's up on this issue. According to the climate models, we have maybe a decade to 15 years to do something incredibly hard, which is to achieve societal transformation to actually escape the worst of this. And we're wasting a lot of time. You know, we get another 5 years of what we've had for the last 3 years. I don't see a lot of hope there.
And Jeremy?
Okay, well, I would say that it's late, but it's not too late. If we had taken action 30 years ago when climate scientists first rang the alarm bells about climate change, I think the job would have been a lot easier than it is now. Now we're already experiencing the negative impacts of climate change, but it's not that we can't do anything. Clearly, the decisions we make, we can slow down the rate of change, and we can come to some equilibrium. So there are things we can do.
All right, well, maybe we can talk a little bit later about how this issue is affected by the rising youth movement that we see recently, and how there's perhaps a generational change in how American citizens are regarding the issue. But the expertise of everyone on the panel is science, so let's go to the science first. We're going to hear presentations from each of these people on their areas of expertise, and let's start with Howard. Is that okay?
Yeah. Well, I think we were planning to have
Okay.
John speak first.
All right, yeah, I did go out of order. Let's start with John.
Oh,
My bad.
now I have to do a good job. I'm going to start kind of from first principles. We've sort of worked it out that other folks will kind of riff off of some of what I'm going to say. I'm going to talk mostly about what global climate change is really all about, and then the potential impacts of sea level rise on coastal civilization. When you look at it from a human perspective, something close to 80% of the human population lives within 50 miles of the coast. So we are a coastal civilization, and if you have a low relief kind of coast, minor changes in sea level rise have a major impact on the coast. Now, the greenhouse effect. Basically, this is not controversial. It's basically chemistry and physics, and the way it works is identical to the way a greenhouse works. Incoming solar radiation has a short wavelength, so it's relatively small. So it can pass through the atmosphere fairly easily. It gets absorbed at the surface of the Earth, the same way surfaces inside a greenhouse absorb sunlight that passes through the glass. Then it gets re-radiated as a longer wavelength type of radiation. For lack of a better term, that's big. And it has trouble escaping back into space because of the presence of greenhouse gases. It hits greenhouse gases, which have chemical bonds which actually absorb the energy, and they trap it in the lower levels of the atmosphere. As far as science goes, this is pretty basic. The climate system is complex. What happens to that trapped heat after it gets trapped isn't so simple, but this is pretty straightforward and not at all controversial. Now, in order to predict what's going to happen in the future, we use climate models. And these are based on different socioeconomic scenarios of how much CO2, how much methane are going to be put into the atmosphere over time. And we usually talk about gigatons of carbon, which is a lot of carbon. And this is why we also talk about the carbon footprint. Basically, your carbon footprint is how many pounds of carbon you put into the atmosphere due to your activities every year. And basically, we'll just stick with CO2 for now. So basically, carbon emissions, if they increase, it results in rising temperatures and rising sea levels. And we can translate these gigatons into actually parts per million of CO2 in the atmosphere. And right now, we're right at about 410 parts per million. The natural highs in the Earth's climate system are closer to 300. So we're already well above what's natural, which is why scientists kind of get exasperated when people start talking about, well, is it man-made or is it natural? It's man-made. There's just no way it can't be. And basically, those socioeconomic scenarios get translated into the scenarios that are, translate the high concentration scenarios. We never take this seriously. We don't do anything about it. You get a blue line, the solid blue line. We take it somewhat seriously, we get a red line. More seriously, a green line. We take it really seriously, you get those lower scenarios. So we sort of talk about the high-end scenarios and the low-end scenarios, and my pitch tonight is we need to do whatever we can to stay on the low-end scenarios, because you sort of look at the fact that they start to deviate around 2030. And 2030 is right around the corner in terms of affecting transformational change in a society. So that's why I'm saying we don't have a lot of time. And these things don't go away very quickly. Carbon, CO2 in the atmosphere, that can last for hundreds of years before it lowers down. So everything we've already put in and everything we continue to put in over the next decade, that has an impact. That doesn't go away. We can't be in the contemplative stage anymore where we're thinking about doing something. We need to do something immediately. Now, where do the models come in? Basically, we have a lot of data that goes back in time, say 1900. We build a model and we use that historical data and we use that to calibrate the model, and we can reproduce past behavior, we can estimate the uncertainty, and that middle line is kind of our best guess of what happens moving forward. And then we feed into the model these different CO2 concentration scenarios, and we come up with high growth scenarios, medium growth, low growth, constant carbon, like Isaac had mentioned. And out comes a warming effect, global warming effect of degrees centigrade. And the high end actually goes up closer to 5 or 6 degrees centigrade on the most extreme models. And we've been told that if we have warming of any more, depends on who you talk to, any more than 1.5 degrees centigrade or 2 degrees centigrade, and this is above the temperature before the industrial age, we start to have these disastrous climate scenarios. If we can keep it below 2, it's bad, but it's not terrible. And the estimates that come out of the models can be keyed directly, temperature can be keyed to concentration of CO2 with error estimates around it. Sort of the median scenario is the vertical line. And you can see that staying below 2 degrees centigrade, that's at about 450 parts per million. We're at 410 now. It's going up about 3 parts per million per year. If you do some simple math, again, 15 years maybe before we hit 450. Now, how much warming can be keyed to how much sea level rise we get. And basically, the warmer we get, the more ice melts. The ice goes back, the water from the melted ice goes back into the ocean. We get more sea level rise. And we have these estimates. You can see, again, the high end. But what you should see on this diagram, which is a little frightening, is that the actual data tracks the worst case scenario spit out by the models. So the models are not working optimally. They're underestimating how much sea level rise we get. So when you take that worst case scenario and you look at the most recent estimates, this is just put out by NOAA, it's geared to the Newport tide gauge. We're looking at 3 feet of sea level rise by about 2050, and 10 or 11 feet of sea level rise by 2100. If you think about Rhode Island, we don't want to see that 9 or 10 feet of sea level rise. And if we key it to key economic areas in our state, and Pam will talk a little bit about, we have tools for doing these reconstructions where you can actually do a reconstruction with this tool and watch your house go underwater in different scenarios. And you can actually estimate how vulnerable your property is. So this looks at the Quonset Point area, and you can see 3 feet of sea level rise, not so bad. 10 feet of sea level rise, very bad. You know, the airport's underwater at that point, and so is most of the industrial park. If you look at downtown Providence, 3 feet of sea level rise, majorly inconvenient. 10 feet of sea level rise, most of the financial district is underwater, and they won't be calling it water fire anymore. Few things like that. Now, one point to make is that all of these reconstructions are just static sea level rise, and then Isaac is going to talk about what happens during storms, because then you get storm surge on top of sea level rise, and Pam will talk a little bit about these tools where we can combine those two things and look at worst case scenarios. Now, probably the worst part of the state with respect to vulnerability is the Warrington-Barrington area. You can see there the 3 feet of sea level rise is very significant. 10 feet, not good. Half the town's underwater at 10 feet. Now, in conclusion, this is why I say time's up. We don't have a lot of time to do something about these scenarios. Climate change is coming harder and faster than the models predict, both for temperature and for sea level rise. We really need to start thinking today about how you can reduce your carbon footprint. If you don't leave here thinking about that a little bit at least, I have failed. I don't like to fail. We need really immediate social political change. Around the turn of the century, we had a climate bill sponsored by John McCain and Hillary Clinton. Can you imagine something like that happening today in our political climate? That can't happen right now. So we have a real social and political problem. We can solve part of the social problem. I guess next year we might be able to solve part of the political problem. I think the technology will help. The development of the technology is coming really fast. We're switching over to alternatives with battery storage much more quickly than anybody ever thought we would, and it's already cheaper than fossil fuel alternatives. I did not see that coming. I thought it would be a while yet, but that's a good outcome. I like to see the children in the streets. I like the sign that said, if your leaders act like children, let the children lead. They're doing a better job than our leaders are. That's kind of where things stand, and I wish I could be more optimistic, but I don't see a lot of reason to be. Thank you.
Before we move on, are there any questions for John about his presentation? Okay, let's go to Isaac.
My research has been focusing on extreme weather. And particularly, I've been working on improving computer models that are used for forecasting hurricanes and storm surge, flooding, inland flooding, coastal flooding. And the computer models are based essentially on the law of physics. And understanding the law of physics will help us to improve our forecasting. And over the years, many of you know that we have made significant improvements in forecasting hurricanes, for example, track in intensity. And that's because we better understand the physics. And when we think about the climate change and the changes that are associated with climate change in terms of the temperature of the ocean, temperature of the atmosphere, we can project what kind of changes it will make on extreme weather. For example, we know the hurricanes draw energy from the ocean. The temperature of the ocean is one of the critical parameters. that determines the hurricane intensity. And if the temperature of the ocean will increase, then the intensity of the hurricanes will increase. Again, this is based on the law of physics. Now, with the increased temperature, the evaporation from the ocean increases as well. And that means the hurricanes will get more moisture from the atmosphere. And if the air temperature increases, the air can hold more moisture. Again, this is the law of physics. So that will imply the hurricanes or tropical cyclones will be able to not only produce more moisture, but also carry that moisture on the large distances. So, and what we are seeing recently in recent hurricanes and flood events, the signatures of what we projected are associated with the climate change. In fact, the changes that we are seeing now is something we thought, the scientists, we will see in 10, 15 years, but they're occurring now. And I want to start with just showing some examples of what kind of extreme weather events we have seen recently. So I'm going to start with actually the hurricane that is taking place today. It's a Hurricane Lorenzo, this hurricane in the open ocean. This hurricane just intensified this morning to Category 4. And of course, we know the hurricanes can intensify. There's 5 hurricane intensities, and the 5 is the highest. What is unusual about this storm, that this hurricane intensified to Category 4, and the far east in the Atlantic, for the first time we ever see a hurricane reaching Category 4 that far east. Typically, hurricanes intensify more to the west, where the temperature is warmer, but this is, again, a signature of the events that we can see more frequently as the temperature of the ocean increases. Now, last week, we had a tropical storm, Imelda, that essentially produced enormous amount of rain in southeastern Texas. Up to 30 inches of rain associated with a tropical storm. 4 fatalities and enormous amount of flooding. A few weeks earlier, Hurricane Dorian, late August, beginning of September. That hurricane reached the maximum wind speed 185 miles per hour. The Category 5 storm is 155 miles per hour and higher. You might say that this is Category 6 storm. And we have actually seen recently a number of these storms in the Atlantic that reached such a high intensity. And of course, that storm slowed down, stayed about 2 days over the Bahamas, and produced enormous amount of damage. So let's now look at last year. We had Hurricane Michael and Hurricane Florence that affected the United States. Hurricane Michael, the Category 5 storm, made landfall in Florida, 59 fatalities. Hurricane Florence was a Category 4 storm, but it made landfall in North Carolina, produced after 30 inches of rain, flooded North Carolina, 54 people died, about $25 billion of damage, including Michael, also about $25 million of damage. Another storm in 2017, Hurricane Irma. Again, the storm reached Category 5, 180 miles per hour, 63 fatalities in the U.S., $189 billion of damage. And Hurricane Harvey made landfall in Texas, up to 6 inches of rain, again with a significant amount of damage. Another storm in 2016, Hurricane Maria, another Category 5 hurricane, devastated Puerto Rico with an estimated damage of $92 billion. A year before, Hurricane Matthew made landfall or affected significantly with a significant flooding in North Carolina again. And then early in the year, in Houston, was a huge flooding in April. 2015, the flooding in Texas, in Oklahoma, again, 2015, early in the year in September, the flooding in both Carolinas, South Carolina, North Carolina. So essentially what we are seeing already, the impact of the global warming on the extreme weather. So we see stronger hurricanes and they produce more rain. And we also see the more frequent high rainfall events not associated with tropical cyclones. Now, another thing what we are observing that actually we did not anticipate, we are seeing that hurricanes in the Atlantic are slowing down. In fact, for the last 20 years, just a recent paper was published, identified that many hurricanes started to stall after making landfall. And this is a very worrisome signature. It's not clear how this is associated with the climate change, but there is some potential connections. So what we probably will be seeing in the future with more hurricanes, with slowing down, will produce more significant damage and the rainfall. So what is the implication for the New England? I think we all need to also think about this. So if you look at the record, the storm that affected Rhode Island, in terms of the rainfall, we had Hurricane Diane in 1955 that produced significant amount of rain, about 10 inches, and then was, Diane was about 18 inches, and then Hurricane Esther in 1961. Very interesting storm. That storm actually made a loop not far from Rhode Island. It stayed over the open ocean, but produced significant amount of rain. So when we're thinking about the future risk in Rhode Island, we have to think about the combined effect of the coastal flooding due to storm surge and the inland flooding due to rainfall that could happen simultaneously. In New England specifically, especially vulnerable because our rivers are relatively short and shallow, so they can fill up rather quickly. And so we have actually recently simulated one storm, hypothetical storm, not real, but hypothetical storm, that could produce significant flooding, coastal and inland flooding. We call this a Hurricane Rudy scenario. So that you see the track of that storm in the red. So the track of the storm was very similar to Hurricane Esther in 1961, but we made that storm actually make landfall twice. So it will come as a strong Category 3, produce significant amount of flooding, and then 2 days later will come and produce significant amount of rain, up to 20 inches. And one question we ask, what would be the effect of the hurricane barrier that was built in the 60s, but it was never tested in big storms? So of course, hurricane barrier was built to protect downtown Providence from the storm surge. But there are two rivers, Woonasquatucket and Moshassuck, that bring the water down to Providence River. If they get flooded and the gates are closed, that could produce significant amount of flooding in downtown Providence. And this is exactly what we have simulated. So this is the image of the flooding in downtown Providence produced by the hypothetical hurricane with a barrier closed solely due to the river runoff from these two rivers, Woonasquatucket and Moshassuck. What was actually surprising in our simulations, that downtown Providence will get up to 15 feet of water in 2 days from the river flooding if the gates are closed. So in summary, these are the scenarios that we need to look more carefully and assuming that storms could slow down, as we have seen now recently, and so we might see a hurricane in southern New England that we have not seen before, with really combined potentially catastrophic effect of the coastal storm surge-induced flooding and the inland flooding due to rainfall. Thank you.
Okay, thank you, Isaac. Any questions for Isaac before we move on?
Yeah, sure. First of all, it's tough to formulate a question immediately after the presentation, but I'll do my best. In your scenarios, and particularly in this one. Where are we in terms of taking this type of physics and turning it into some type of policy? Like, how close are we to doing that? I know of at least one a bunch of cases where houses, particularly built along the Cape, some of the coastal areas get flooded, get torn down, and then here we are, our taxpayer dollars get to rebuild them again over and over again. But those policies are still in place that we can do that. So where are we in getting that physics to the level of policy?
So Pam will speak more about this, but this project is funded by the U.S. Department of Homeland Security. And our first priority is to make the emergency managers aware of these potential scenarios for Rhode Island. In fact, the Rhode Island Emergency Management Agency already has done training exercise based on this scenario that we have developed. Because usually, the emergency managers are trained based on the historical storms. So 1938, 1954, those storms, the biggest storms that affected Rhode Island recently, they passed to Rhode Island rather quickly. And with this scenario of combined rainfall and storm surge, that will create a significant more challenges for emergency managers. And one of the questions we raised is, how would you open the hurricane gates? It turns out, after the first landfall of Hurricane Rory, with a wind speed up to 130 miles per hour, the entire state will be without power. It's been estimated by the Department of Homeland Security. And then we learned that the gates could not be opened without the power. So that is one of the scenarios. So at this point, our first priority is to make sure that we are prepared to deal with this type of events. And of course, another question is, what are the long-term implications in terms of how we build, where we build, and to look at the policy. But Pam will discuss this more.
Okay, it's Pam's turn.
So I will try to answer some of the questions that came up as I go. So my role at the university is to take some of the science that we've heard tonight and to help to transform that into messages and programs and tools that people can use either in their communities, in their businesses, or perhaps in the state policies, of which one of them we'll talk about. So we'll be learning a little bit about knowing your risk, making a plan, and taking action. So just kind of as a public service announcement, September is National Preparedness Month, and so you could really look online at ready.gov. But the Red Cross, many of you probably have seen this, has the 3 key actions: get a kit, make a plan, and be informed. And really what I'm going to be speaking about is using that paradigm and really transforming it into what individuals can do, what organizations can do, what communities can do to be more prepared. And so let's start with know your risk. So John spoke a little bit about some of the tools that are available. And many of you might have heard about storm tools developed by the university and the Coastal Resources Management Council. Well, this goes one step further with storm tools to help address the gentleman's question here, which is, how do you transform that into policy? So the Coastal Resources Management Council now has a coastal hazards viewer that basically has a viewer and a worksheet for developers, people who are developing along the coast, to evaluate their properties for what storms look like. So not only storms today, but storms in the future with sea level rise. So for any given place along the coast, you could look at these maps, storm tools, or this is a storm tools design elevation, and you could really look at what is your 100-year storm, or really, which is equivalent to around the Hurricane Carol that Isaac spoke about, plus 3 feet of sea level rise. So if you're building a house or a property that might have a design life for 30 years, you really need to think about that 3 years of 3 feet of sea level rise. And so this could then start to tell you where the water would be during a storm in the future. In Rhode Island, this is provided as advice. It is not a mandatory requirement. However, the state has gone further in the permits that they look at, that you have to put that into your permit asset so that that goes along with the property. But again, this is voluntary at this point. It will reduce flood insurance for those that are in flood insurance to elevate to higher standards. In the town of South Kingstown, they've taken that in addition to a little bit further, because it's not only along the coast, they've incorporated into their floodplains and then their future floodplains, and they've put it in their zoning ordinance as something. It's, once again, it's not mandatory, it's voluntary, but any project that comes in these areas, people will get the information about what the future floodplain will look like. And that information goes into a land evidence record. So when you sell your property, people will be able to know, once again, what the risk is. Prep RI, providing resilience education for planning in Rhode Island. It was very much recognized that volunteer boards, planning boards, for example, are volunteers, and they don't necessarily know the information that you're hearing tonight. So there's a requirement for all planning board members to have at least 2 hours of education. So they know the risk so that they could bring that to some of their decision makers. This is a 6-part series, around 10 to 12 minutes each, where you could look online and you could see a video of really informing what is your risk, managing stormwater, infrastructure at risk as well. So let's go on to make a plan. So setting the stage, a few years ago, there was legislation to really move Rhode Island ahead in trying to understand and act upon climate change. And so just about a year ago, Resilient Rhody, the statewide plan, was passed with a lot of different public input, different agencies, 11 or 12 different agencies, and it really provides a blueprint for the state to move forward. Very exciting. It's not only just a plan. The 2018 Green Bond, many of which I'm sure you all voted in the election. Many of you probably even voted for the Clean Water Bond because it really passed very highly. And that really incorporates different money for infrastructure and resilience projects. And so we'll be seeing some of those projects start to be planned very soon. Also, as part of Resilient Rhody, municipalities have been selected to start doing municipal planning. And so there was 5 municipalities that recently went through a program: Portsmouth, South Kingstown, Westerly, and then Barrington Warren that John mentioned, were the first group that went through a planning stage of looking at what are their assets, social, environmental, and infrastructure, so that they can start to act on those as well. And they will be able to access some state money from the Rhode Island Infrastructure Bank to start taking action. And then all communities now have their community conservation, their comprehensive plan incorporating climate change and sea level rise. So not only at the municipal level and the state level, we need citizens really taking action. Here in Providence, civic leaders are collaborating in the Providence Resilience Partnership. This is a group of people that are starting to coalesce over the past year, and their goals really are to devise innovative strategies, build consensus and support for taking action, and assure implementation of effective solutions for Providence. That's a project that includes Water Fire Providence, URI, Brown, as well as the Providence Foundation, Lifespan, the Episcopal Church, and many other organizations really trying to get their arms around what are some of the issues and how can we act. businesses are starting to take notice and action as well. So here, the state has just recently developed 8 different guidebooks for different kinds of sectors, from restaurants to water-dependent businesses to construction. And they really have this opportunity now to look at some of the different tools that you could use, from elevating to looking at what are some of your assets, such as your equipment. What can you do to protect your equipment during a storm? What can you do in the future to deal with sea level rise? So for each of those different sectors, there's different recommendations. Here on your right, you see Sam's Snack Shack in Westerly. It used to be a brick and mortar business that was destroyed during Hurricane Sandy, and now it really is more of a portable unit, whereas if there's a storm, they could take their trailer off-site so that they are more resilient to impacts. So more on the taking action. Common Fence Point is one of the vulnerable communities in Portsmouth. They recognize this, and we're working with them to on their new preparedness committee, where they have identified some key actions and some key assets that they want to protect. And they are moving ahead as a neighborhood of 700 households. And so this is where we really need, from the ground up, a groundswell of action and awareness. And so they definitely are taking action. Restoring habitats. The state has worked a lot. Coastal Resources Management Council, Save the Bay, amongst others, have really been working to restore some of the habitats that have already been impacted and will be impacted even more. Our wetlands. Our wetlands are our nurseries. Jeremy will talk more about the wetlands issues, but we're starting to see a lot more action because a lot more impact is happening before our very eyes. Individuals are starting to look at how they could adapt to some of the changing conditions. Houses are being raised in vulnerable areas. And then on the right, Carpenter's Beach, many of you might have heard them on the news lately, in the Washington Post, etc. They are used as an example in South Kingstown of how people are doing managed retreat. That store over here to your left, that first small arrow, is being moved for the second time back because erosion is impacting them. Houses that were damaged during Superstorm Sandy have been moved back towards the cornfield. And this is an erosion issue. Erosion is more closely aligned with storms, but as you heard Isaac say, we're seeing more intense storms, and the erosion is just continuing here, the highest in the state. So what can you do? So we talk about that. You too can really start to stay informed. Know the facts, the implications, the costs and benefits of taking action, and more important, what are the costs of not taking action? You and your family can make a plan. You can encourage community action, as we've talked about tonight. You could support legislation, both locally and nationally. You can prepare or build your kit. You could make some personal decisions on what you need to do, take actions to both reduce your carbon footprint and to adapt to change. And finally, this weekend, we will be seeing some extreme high tides. And this is a picture of high tide here in Providence Water Place Park, excuse me. And as some of us would know, Barnaby's in the audience, that we're seeing more and more impacts of high tides there. Well, it's not just our imagination. A report just came out from NOAA that really showed how extreme high tide, or sometimes they call it nuisance tide or sunny day flooding, has increased. In Providence, in 2000, we had around 3 days of extreme high tide flooding. In 2018, we had 18 days. And the projections for 2019 are 5 to 10 days. And you could see here by 2050, 40 to over 100 days of extreme flooding. And even though we have a hurricane barrier, that cannot be stopping the sea level rise. So why I encourage you to go out and look at tides this weekend, early in the morning, go on to mycoast.org. You could go to your local community and take some pictures and put it up on the web, and you too could add to the science that is being developed. Thank you.
Thank you, Pam. Do we have any questions for Pam?
I'll ask the same question. But perhaps from a different point of view. So the policy is voluntary. When does it become mandatory? Why aren't we creating a no-build area? The recent storm, Dorian, leveled an island or two, and now they're thinking that perhaps they should just abandon that area from now on. So where are we? How close are we to Carpenter's Beach, for example, or the Fame Tower on the floodplain, or any of these other examples that you give? Where are we, and why can't we muster the courage to say, that's enough, it's not going to happen?
I think it's a really good point, and I think that while the tide is changing quite quick, and I think that people are becoming more aware, they're still not ready to make that commitment. And it really does take political will. One of the reasons we're working at the very local level is to try to get people to understand, like yourselves, in their neighborhood, to see what is the challenge, what are some of the opportunities here, and that they can hopefully have a groundswell of effort that can then influence their town council and their state legislators. There's a lot going on right up the street on the Hill that is not being passed because there's not enough voices out there that are saying we need to make this change. I think people are really concerned about their bottom line. I've seen businesses, marinas, for instance, say, no, I haven't seen the sea rising. People don't want to believe because then they have to realize that their investment might be underwater soon. And so that's a real concern. So I really think that it's getting more people aware that this is happening, that it's not changing. And when you see John's pictures, when you see Isaac's science, this is real science, this is really happening. And then when you see that the rains are coming and the tides, I could tell you what the report said, but you might not read the report, you'll see what's going on in your waterfront, that people are going to start to demand change. Up until now, we haven't had a consensus amongst our politicians that things need to happen that quick.
Did we have another question for Pam in the audience?
Yeah, I mean, you might have answered that question, but in your conversations with citizens and members of a governmental members of a given municipality to create these comprehensive plans, what aspects of those conversations have you been most challenged by, and also most surprised or positive, or are there any sort of positive messages that you've taken out from those conversations?
So the question revolved around conversations with the community and what have I been most surprised by, or challenged by, I should say. Challenged by is the money. I can't remember exactly the quote, but when the town manager of my town, South Kingstown, talks about how much tax revenue will be lost in property values during, for future sea level rise, and then how many homes could be affected during an intense hurricane, it's alarming. And so, on the other hand, they're saying that 80% of our taxes are going to our schools. So citizens have a real challenge, and town managers and state managers have a real challenge in really how to be innovative and creative about financing. So I think that that's the hugest challenge, besides the getting people to wrap their heads around this, and people to take change personally, and then in the community and at the larger level, it's the finances that we really haven't identified real innovative and creative solutions to some of the finances. If we did, I think that people might be a little bit more willing to admit it. The surprising, over the past, I'm going to say 3 to 5 years, people have really started to understand that this is happening. And so I'm really hopeful that as we say that we really need to make change, there really has been a big change where perhaps it's because we've been seeing these storms, as Isaac so eloquently went through over the past 5 years, that people in the communities are saying, yeah, this is happening, I'm seeing change. And that really has been surprising lately, because surprisingly good, because people were not seeing it before.
Okay, our next speaker is Jeremy.
So I'm Jeremy Colley. I'm a biological oceanographer. So I guess you could say my role is to speak out for the fish and the other animals living in the ocean. And I think when we talk about the impacts of climate change, it's natural for us to look first on land, because we live on the land. And I think the impacts are much more visible to us on land when you think about things like effects on agriculture, forest fires, extreme weather events that Isaac was talking about. It's much more apparent to us. But I think one also has to think about the role of the ocean. Obviously, the ocean plays a huge role in modulating our climate. So, for example, a quarter of the carbon dioxide that we emit is absorbed by the ocean, and about 90% of the excess heat is also taken up by the ocean. So clearly, it's playing a great role in sort of buffering the effects of climate change. So to try to make this transition from the land to the ocean, I chose this slide about salt marshes. So salt marshes play a very important role in Rhode Island, but all along our eastern coast. And one of the main roles they play is that they buffer the coast against the storm surge related with storms and help protect the shoreline. But beyond that, we know that salt marshes are a very important habitat for shellfish, for juvenile fish species, for birds, and some of these species are actually already endangered. So they're very important biologically as nursery grounds. So I'm really just going to make 3 main points tonight. The first one about the importance of salt marshes. So as sea level rises, salt marshes can adapt to some extent. And it's interesting that in our state, we have some excellent programs where groups are restoring salt marshes that have been degraded, and by replanting them and trying to restore them to a healthy condition. And they're making some great progress, but it's really just a drop in the bucket when you consider how little the area is that we're restoring and the vast expanse of salt marshes. So to some extent, salt marshes can rise with the sea level. They can accrete by depositing sediment, but that's a very slow process. That's millimeters. And so it's really going to be impossible for salt marshes, despite our best efforts to restore them, to actually keep pace with rising sea level. The other thing that can happen is that salt marshes can migrate inland if there's room for them to migrate and it's not built up. So to some extent, salt marshes can migrate inland. So people at the Coastal Resources Center and the CRMC have made calculations of this. And so you can see the calculations here. This is with 1 foot, 3 foot, or 5 feet of sea level rise. You can see the loss in acres that's predicted for salt marshes in our state. And so with the 3 feet, that's 1/2 of the current salt marsh would be inundated. To some extent, there's some new marsh would be created, and so there'd be a gain, as shown there, with the 3 levels of sea level rise. And so the net loss then is the difference there. And so you can see with 1 foot, okay, that would be okay, that we'd be able to gain as much as we lost it. But with any of those scenarios, with 3 feet or higher, the net loss would be a net loss of a large percentage of salt marshes. And if you remember from what John King showed, that the 3 foot sea level rise is kind of like what we expect by 2050. So it's be almost impossible for salt marshes to keep up with the rate of sea level rise. Okay, so marine species are on the move. Now you might think, well, we've got a lot of problems here with our buildings and all that kind of thing.
maybe the fish can take care of themselves. They already live in the ocean, so, you know, in a sense you could say, well, they're adapted to changing climate. And to some extent that's true. But what we're really seeing, though, is that the distributions of marine species are changing more rapidly than it's ever been observed before. This slide is showing the change in the abundance of the American lobster in 5-year time blocks. So red is high abundance and the blue is the low abundance. And if you look at that long enough, you can see that abundance is shifting from the 1970 to where lobsters used to be abundant in southern New England. And in fact, right off our coast was hot spots. But by the end of this series, by 2010-14, you can see that the largest concentration of lobsters is in Maine. And that's good for Maine now. Maine has had record lobster catches, but even that window is going to be fleeting for Maine. Eventually, the water is going to be too warm in Maine as well, and all the lobsters will be in Nova Scotia. So when we talk about marine species on the move, you know, sometimes people think, well, the lobsters, what are they doing? Are they kind of packing their bags and walking north to Maine? And that's not quite what's happening. It's that their thermal habitat is shifting, and shifting faster than ever before. Lobsters can walk a long way, but it's not that they're moving to Maine, it's that the habitat here is deteriorating and the habitat in Maine is ameliorating. So when you think about climate, you can think about, from our perspective, there are losers and winners. Lobster, I guess, is a climate loser from our perspective. There are species that are becoming more abundant, and so there are, in a sense, climate winners. And I'll just point out one of these is the striped sea robin. And I'll take just a minute to put a little bit of promotion here that at the Graduate School of Oceanography, we run one of the longest time series of trawl surveys in the world. And so every week since 1959, we've been going out into Narragansett Bay and sampling the fish fauna. And not only do we have a long time series now, it's 60 years old, that since we go every week, we can look at the seasonal timing of when species are arriving and when they're leaving. And striped sea robin is an interesting example because it's a species that at the beginning of our time series, back in the 1960s, striped sea robin was actually quite rare in Narragansett Bay. And what that graph on the bottom is showing is how the occurrence, those are days of the year, and you can see by the diagonal lines that sea robins are coming, striped sea robins, they're coming to Rhode Island earlier and they're staying later. So they're spending more of their summer vacation in Rhode Island, shown there by especially the blue extremes. That's the date of first arrival and egress at the end. And so while striped sea robins are here, they're feeding a lot. You can kind of see the sea robin there. And I don't know, have any of you ever seen them in the water? You look down and you see them, their wings out there. Yeah, they're pretty nice. What they're doing is they basically are swimming along the bottom, hoovering up the bottom. And they'll eat. We've actually done a study this summer about looking at the diet of a striped sea robin because it hadn't been very well studied. And we'll find that, you know, they'll hoover up pretty much anything in their path. But in particular, they're eating things like baby lobsters. You often find them in the stomachs of sea robins and juvenile winter flounders. And these are kind of the loser species that we're concerned about. So it's kind of a double whammy. The climate's getting worse for them, and also we have new predators that are eating them. So thinking about climate winners and climate losers is kind of a simplistic thing. What's happening is that we're really changing the balance between predators and prey that have evolved over thousands of years. We're upsetting that balance, we're upsetting the food web, and creating these novel situations of predator-prey dynamics. So I'll just end by saying that when we think about fisheries, that it's really actually what's happening in the ocean is really very important. Globally, there are millions of people who depend on seafood as their primary source of protein, and there are thousands and thousands of fishermen who depend on fishing as their source of income globally and also in Rhode Island. So it actually is also a very important issue of what's going on in the ocean. So with that, I'll end. Thank you for your attention.
Any questions for Jeremy before he sits down? Okay, last but not least, it's Howard.
Okay, I am going to talk about the effect of climate on vector-borne diseases. And if you look at cases of vector-borne diseases in the United States. These are CDC data. You see that Lyme disease is the big one. And in fact, that is true of north temperate areas worldwide. Tick-borne diseases are much more important in the temperate than are mosquito-borne diseases. That switches when you get to the tropics, where mosquito-borne diseases, dengue and malaria, become more important. So let me talk about a few of these diseases and how climate might affect their distributions. So we'll start with Lyme disease. Lyme disease is a disease primarily of wild animals that is transmitted by ticks. It's a bacterial disease. They're the bacterial spirochetes. Typically, one tick in an area is the primary vector, but there are a whole variety of vertebrate hosts that can serve as reservoirs with bacteria. Now, there's been an interesting distributional problem about Lyme disease that people have had a hard time figuring out, which is, you look at the left figure, that's a CDC figure showing the distribution of the ticks that transmit Lyme disease in North America. And if you look in the eastern and central U.S., they go north to south. However, the distribution of human cases is on the right. They're in the north, relatively few in the south. Why is that? People have known about this for a long time and didn't know why. It's important to know the answer to that question if you're going to figure out how climate change might affect the distribution of this disease. So I've been involved in a kind of a large-scale study with several universities. I'm the federal scientist with the USGS and fellow from the Public Health Agency of Canada, trying to figure out what are the ecological reasons for that distribution. And I'll kind of give you just the headline results, rather complicated results overall. But the first one has to do with the host-seeking behavior of the ticks. Northern ticks seek hosts on top of the leaf litter. That figure there shows the green are ticks from northern sites, and we put them in little outdoor enclosures with natural habitat and saw how they were seeking hosts. The northern ticks go on top of the leaf litter, on the leaves and on twigs. Southern ticks stay below the leaf litter surface, in the brown there. Whether you do the experiment in Wisconsin, Rhode Island, Tennessee, or Florida, it's always the same. The northern ticks on top, southern ticks underneath. That means if you walk through the woods in the north, you're walking right through the tick habitat. You're getting them on your feet, they're crawling up and biting you. In the south, they're underneath the litter surface, so you're walking on top of the habitat, you're not encountering the ticks. So one big answer to the question is that because of the difference in behavior, of host-seeking behavior, there are a lot fewer tick bites in the south, which is in fact correct. This might actually be climate-related because if you look at the warmer temperatures in the south, that creates kind of desiccation stress at the surface, so the ticks might evolve to stay underneath the surface to avoid that desiccation stress. Okay, so that's one factor. Another important factor is host communities. In the north, you have mammals and birds, all which can serve as hosts for the bacterium. Same thing in the south, but in the south, you have a lot more lizards than you have in the north, and particularly the skinks, and like that five-line skink there. Turns out these ticks love skinks. When we had sample sites north to south, the most common hosts we get in the north are mice, and that's where most of the ticks are. When you get to the south, there are plenty of mice, but there are also lots of lizards, and the ticks are mostly on the skinks. Now that's important because mice are very good hosts for the bacteria. Lizards are not. So not only are you bitten by fewer ticks in the south, but the ticks that bite you, a lower proportion of them are infected because they've been feeding on lizards, not on mice. Okay, so what does this imply for distribution of effective climate change on distribution? Well, Nick Ogden, who is a Public Health Agency of Canada, one of the people working on our group, has done some simulation modeling of the tick life cycle and the transmission cycle. A very complicated model, but he first published that in 2005 and predicted how distribution of ticks and Lyme disease would be expected to change in the northern parts of the range. And in fact, that model has turned out to be pretty much right on the money in terms of how things have changed. These ticks and Lyme disease will be moving north into northern parts of the US and into Canada. That is already happening. Southern part of the range, though, is kind of interesting. In view of what I've told you, the southern part of the range right now is kind of the Chesapeake Bay area. Well, what happens if the climate warms? Well, it could be that those ticks in that area will start behaving more like southern ticks, and stay under the leaf litter, so there might be less tick biting in that area, and they might feed more on lizards, so that you may be less Lyme disease in Maryland and Virginia in the future than there is now. It's not 100% clear. There is some evidence of northern genotype ticks moving south along river valleys near the Blue Ridge into Tennessee. That may be happening. It's not clear yet, but those are the parameters that we have to understand to figure that out. Okay, so let's get to mosquito-borne diseases. One very important mosquito-borne disease on a worldwide basis is dengue fever. There are 2 species of mosquitoes that transmit that disease in the Western Hemisphere. Neither of is native. These are both introduced species. One on the left is a yellow fever mosquito, Aedes aegypti. One on the right is the Asian tiger mosquito, Aedes albopictus. Aedes aegypti was introduced to the Western Hemisphere from Africa, probably on slave ships in the 1600s, most likely. Aedes albopictus was the Asian tiger mosquito, was introduced into Texas in the 1980s in a shipment of used tires. Used tires, they collect a little water and mosquito larvae are in there. That was introduced. Now, if you look at the distribution of those 2 species now, Aedes aegypti is a warm weather mosquito. That's mostly southern U.S. It cannot survive the winter in Rhode Island. I don't see that being an issue. Aedes albopictus was introduced from northern Asia and is now spread over much of the eastern central United States. It's already here in Rhode Island, not in large numbers, but it's gotten here in the last few years. So that's a vector of dengue and also chikungunya and Zika virus. Are we going to have problems with those viruses, dengue in particular, in Rhode Island? Well, climate is very important in figuring that out. The reason is that there's a cycle of kind of extrinsic, what's called an extrinsic incubation period. There's an incubation period of the virus in the mosquito. When the mosquito takes a blood meal, picks up the virus, then the virus has to get out of the midgut, go replicate in the mosquito, and get to the salivary glands. That's when it can be transmitted. That takes a period of time, and that period of time depends on temperature. So there's some CDC data on the left showing, look along the temperature on the horizontal axis, and the vertical axis is that extrinsic incubation period in days. So when it's warm, it happens very quickly. When it's cool, it happens much more slowly. So the implications of that for transmission, the ecology of transmission, I've kind of did a figure on the right to show that. The blue line there is the survival pattern for mosquito. Mosquitoes, rule of thumb is 10% mortality per day, and that applies actually pretty well to the Asian tiger mosquito. And what I've done there is, let's say a mosquito picks up, it emerges, it starts looking for a blood meal, takes an infected blood meal on day 3 after emergence. 83 degrees Fahrenheit, that's the mean temperature in the month of August in San Juan, Puerto Rico. That's when a mosquito in San Juan would first be able to transmit the virus. As you can see from the survival curve, at that time about a third of the mosquitoes are still alive. So you have a lot of infected mosquitoes able to transmit the virus, potential for an outbreak. In fact, in Puerto Rico, you do intermittently get outbreaks of dengue fever. 75 degrees, that's the average annual temperature in Hempstead, Long Island. I used Hempstead because I first gave this talk at Hofstra, but all right, that's Long Island. At that temperature, the mosquito would first be able to transmit the virus day 25 to 30. Maybe 5% of the mosquitoes are still left alive. So with that kind of situation, you would not likely have an outbreak. Not enough mosquitoes are left alive to transmit. You might have occasional transmission. In fact, on Long Island, there was one known mosquito-borne transmission of dengue in 2013. That's the only case that's ever been seen. It fits this kind of analysis quite well. What that means is as climate warms, dengue is going to move north. There's no question about that. Will it reach Rhode Island? Very unlikely. Who knows, maybe under some of the extreme scenarios it might, but that doesn't seem to be likely. Okay, let's talk about the disease that is now on people's mind in Rhode Island, Eastern equine encephalitis. Now this virus has a very complex transmission cycle, and I'll tell you right now, it's going to be very hard to predict because of climate change. I'll talk you through it fairly simply. There's an enzootic vector. Now, this is a virus of birds. The enzootic vector is a species called Cuticida melanura that lives in swamps, freshwater swamps. So that mosquito almost exclusively bites birds. So it gets the virus going in the bird populations, and you have a period when the virus in birds builds up. Now, a bird doesn't stay infected too long. Most of the native birds are adapted to this virus. Their immune system clears the virus out of the blood fairly quickly, over a matter of a few days. So first you need that virus to get the the virus amplified in birds, and then just when there are a lot of infectious birds, which again doesn't last that long, you need another mosquito that has a very broad host range that might bite a bird and then fly out of the swamp and later bite a person. Okay, those are called bridge vectors because they bridge from the natural cycle to humans. So here are the seasonal activity periods of the three species we're kind of concerned with in Rhode Island this year. It varies, the bridge vectors can vary in different years. These are means of 6 years data from Connecticut. Cuticida melanura builds up, that midsummer period between the dashed lines, that's when the real amplification is occurring. There are large populations of Cuticida, it's biting lots of birds, there are a lot of infectious birds at that time. If you happen to have an emergence of just the right bridge vector species at that time, and flies into the swamp and bites a bird, or bites a bird that's flown out of the swamp, it then goes through that extrinsic incubation period, which can range from 3 to 20 days, and then it could potentially bite a person and infect them. So most people are exposed to this virus in late August, early September, because of that seasonal cycle. So you see, there are all these environmental coincidences that have to happen for this virus to ever get to a person. You need large numbers of the enzootic vector, you need the virus to be introduced, you need the right birds in the swamp, and you need an emergence of just the right mosquito bridge vector species at just the right time to pick up the virus and then later by humans. Now, since this all occurs in swamps, that's one of the reasons it's rare, because there typically aren't large numbers of humans near swamps. But when you have a human population center near a swamp, like westerly near Chapman Swamp, that's when you are concerned about this getting to people. Okay, so how is climate change going to affect that? It's a very complex cycle. There are a lot of coincidences required. Very rare, I mean maybe 5 to 10 cases a year nationwide for the reasons I described. So it's hard to predict how climate change will affect that. Plus, if you look at the current distribution, it goes all up and down the eastern seaboard. It's not clear that climate change will have an effect. But one thing climate change does do is it affects temperatures, especially during cooling periods in the fall. The top figure there, I took weekly average temperatures in the month of September for 5 years in the late 1980s and 5 most recent years. If you look in late September, it's all the recent years that had the warmer average temperatures. Now, the reason that's important is because mosquito biting declines fairly precipitously when you get into the 50s Fahrenheit. You know, if you get below 60 degrees Fahrenheit, biting drops, and if you get in low 50s, it drops considerably further. Now, so since most of these species are most active, the ones that bite people, are most active at sunset, if the temperature is below 60 degrees at sunset, the risk of human infection goes way down. And in fact, in the 1980s and the 90s, typically the last week of September, it was below 60 degrees at sunset. I took a screenshot there from Weather Underground, and you can see, if you can see the temperatures at sunset, they've been around 70 degrees this week. That's for this week. So, you know, the take-home message is, if you have a barbecue, get indoors before sunset now. But whether that will mean it'll extend the biting season later into the month, it might well. So that's certainly a plausible effect. So I'll stop there. That's the tick crew, and take any questions.
All right, any questions for Howard before he takes a seat? Okay, thank you for those presentations. Very interesting, very informative. Let's open it up. Are there any broader questions about climate change for our panel or for myself? Okay, well, I guess not. Well, all right, Barnaby.
I have a question for you. First of all, thank you for the panel. It was a great presentation. Our challenge is the people who need to hear it are not in the room. And that brings me to Ian, in both media and your sense of how one conveys science that's quite well established and has been for some time, and gets through the social process of making, motivating politicians and citizens to action. But what are your thoughts?
Yeah, I mean, I think, I think many of us here have had the sense of the importance of this issue for years, decades. I heard an interviewer with a journalist who does a newsletter on climate change. She was on public radio. I think she was talking to Terry Gross on NPR, and she talked about how the first President Bush, George W. Bush, announced some initiative about climate change and was going to make it a big focus. And this is, we're talking about the late 1980s, early 1990s. And so obviously there's been a lack of follow-up by state and the state governments, federal governments since then. And, I think it's I'm struck by the visibility of the Sunrise Movement, which has been present in Rhode Island and other states, and which has been elevating the issue of climate change. And I'm going to offer a little bit of a meandering answer, so pardon me. But, back when I was at the Providence Phoenix, before I came to public radio 10 years ago, I did a story talking about how you can go to downtown Providence and look at the hurricane barriers, markers from the 50s, and see how the flooding on Weybosset Street or Dorrance Street or where have you came up yay high, and how because of climate change we could be looking at stuff like that again in the future. And then, as now, it was clear that the challenge is how do you get people to take steps in the short term for a grave problem that is approaching, but approaching slowly, and the impacts are slowly. So, I don't have a good answer for that. I know that as someone who reports on politics, I know that politicians tend to respond more when people focus attention on an issue, such as the Sunrise Movement is doing. I think climate change is a more urgent issue for the younger generation of Americans who are coming up now, and they are speaking out more to their elected leaders about that. So I think that increases the likelihood that over time we'll see a stronger political response. Will it be soon enough? I have no idea, but I guess that's how I would answer your good question. Paul?
Thank you. Just a quick question for Howard. Is this the new norm for certain types of mosquito-borne diseases? Are we expecting to see more of these? That's part number one. Part number two, you got any advice on what insecticide to use when you go take a walk in the woods?
Okay. I think, obviously, as I described, climate change will affect the distribution of these diseases, but there are a lot of other things that are important. The worldwide transportation, the constant introduction of new pathogens and new vectors, this is happening all the time. So a lot of things, changing landscapes, these all affect disease. So new normal, yeah, but it's kind of moving target, It's hard to predict exactly. There are people doing that. There are groups, international groups, and groups in government trying to, figure what happens if Rift Valley fever is introduced into the U.S. Are there mosquitoes here that could carry it? The answer is yes, by the way. But so there are people trying to figure this out, but it's difficult. It's a moving target. In terms of repellents, there are a whole bunch of repellents that work quite well. DEET, picaridin, plenty of others. Those work quite well. If you're worried about Lyme disease, which is the big issue here, feet, shoes, and pants, they're climbing up, and once they get under your pants, you won't feel them. But for mosquitoes, it's the DEET is a standard repellent. Yeah.
My question is for Dr. Fowley and perhaps Ken too, talking about salt marsh migration. Has there been any push whether it's grassroots or from the state level, to protect areas surrounding salt marshes to sort of, over however many years, to anticipate that salt marsh migration and to maybe prevent, buildup in one area because the expectation is that the salt marsh will move there.
Yeah, I think that's a yes, but I think you can address that one.
So, probably around 4 years ago, we did the mapping that looked at the progression of salt marsh on all of the coastal wetlands in Rhode Island. And that's where we started to look at what it looks like from 1, 3, 5 feet of sea level rise, which is where the numbers that Jeremy discussed came from. From that, I think that they're starting to look at how might you prioritize your wetlands, because obviously there's limited resources and in terms of purchasing land. But then in terms of managing it, they're looking at, how might we look at the coastal buffers, which already are a regulation, but how might we need to change those in the future? In conversations with land trusts, who are our stewards of land in many instances, water in other instances, their feeling is that coastal land is so expensive that they can't really protect it, they can't buy it. And so there's this debate about they would like to protect and purchase waterfront land where the wetlands are, but it's really a hard sell to buy something that might be underwater in the future. So it's a real challenge for that. And so there have been some successes in talking to landowners. I've talked with Wenley Ferguson from Save the Bay, and for instance, a golf course in Jamestown used to mow down to the water, not realizing that that was some of the salt marsh that was starting to come up. You start to hear that in Narragansett on town property, and in Bristol at Cold State Park. So some of the practices are starting to change with the awareness that some of this grass really is salt marsh. But I think that that's really something that has to come out further as well. It would be really good to identify ways to do that.
Right, any other, yes?
As far as involving the community, will you guys be meeting soon again? Any plans for forming a group with the public to every so often get together and keep this awareness process going? What are your plans as far as this type of thing in the near future, let's say?
I guess I'll speak to that. Well, first of all, I will say that the people around me have been very, very generous with their time and efforts to try to get the information out.
Okay.
I think that's my job is to try to work with communities to find the needs so that we could get the venues to get the information out. I used 2 examples, one in Providence, another down in Portsmouth, where the communities are really starting to, or parts of the communities are really starting to take notice. And one of the first things they want to do is to share information. So in both of those instances, they really want to understand what's going on, and not only understand it for the people in the room, but really to share it with the broader community. And so we're trying to figure out ways to do that. And it's a challenge because, as you can see, many people have many other things to be doing in the evenings. People are overwhelmed by emails. People are overwhelmed by different kinds of social media. So it's really a moving target, and we're really trying to identify best ways to do that. So we take suggestions, and if there's venues, opportunities, ways that other people have been successful, we go into people's living rooms. So it really is a big thing, and we really need the larger community to be able to learn, so that you all could then go share some of this as well.
All right, well, let's give our panel a hand. They've been terrific. Thank you to Stephen and URI for helping to bring this together, and thank you to you for being a great audience and for coming out this evening.